This video is covering Chapter 3 of Geometry, specifically Section 3.7 and 3.8. By the end of this video, you should know what concurrent lines are and what role they play in the geometry of triangles. So first, we obviously need to know what concurrent lines actually are. So they are lines that intersect in a single point. So this may not seem like a big deal if you just have two lines, because any two lines that intersect are going to do so at a single point. But if you have three lines that intersect in a single point, this creates an interesting situation. And so the point of concurrency is this point of intersection right here. So now we're going to move on to some conjectures about concurrency and triangles. So this one says the three angle bisectors of a triangle are concurrent. And so the point of concurrency that they create is called the incenter. And so it's going to look something like this, so we have a triangle, and then the angle bisectors go like this, and like this, and like that. So these are all going to create, I know my drawing isn't perfect, but and then they're all going to intersect in the single point, which is the incenter. So now we have our second conjecture that says that the three perpendicular bisectors of a triangle are concurrent. And the point of concurrency that they create is called the circumcenter. And so this is going to turn out something like this. So we have our triangle, and then a perpendicular bisector going that way, and then another one like that, and our third one like that. So these are all going to be perpendicular bisectors, and they're concurrent at this single point called the circumcenter. Okay, so now we're going to move on to the third one, which is that the three altitudes of a triangle are concurrent, and the point of concurrency that they form is called the orthocenter. And so what this will look like is we have an altitude here, an altitude here, and an altitude here, and they all are concurrent at this point, the orthocenter. Okay, so now we have two more conjectures. The first says that the circumcenter of a triangle is equidistant from each vertex. So the circumcenter again is going to be the perpendicular bisectors. So on this triangle it looks something like that. These are all perpendicular, and as you can see, if that's the circumcenter, the distances there, and there all look about equal. Then we have the incenter, which is the point of concurrency of the three angle bisectors. So if we have here, here, and here, is going to be equidistant from each side. So then we can look there, there, and there, and my drawing is a little rough, but those all look about equal. So now we have some more vocab. So if a circle is circumscribed around a polygon, that means that it touches each vertex of the polygon exactly once. So here in this drawing, the circle is circumscribed around the triangle. Inscribed, then, is the opposite, where you have a triangle or another polygon, and the circle touches each side of the, that's a bad drawing, but you can see it touches each side exactly once. So now we have another conjecture that says that the three medians of a triangle are concurrent. So medians go from the halfway point of a segment to the opposite angle. So that will look something like that, and as you can see they're concurrent, and that forms the centroid, which is, so that is the point of concurrency of the three medians. And so the centroid is important because it divides each median into two parts so that the distance from the centroid to the vertex is twice the distance from the centroid to the midpoint of the segment. So here in this picture you can see this length is going to be half of this longer length on each median. So now we've learned about 4 points of concurrency within triangles, which is the centroid, the circumcenter, the orthocenter, and the incenter. So 3 of these points of concurrency always lie on the same line. The Euler line is what it's called, and that is the orthocenter, the circumcenter, and the centroid always lie on the Euler line, and this is regardless of the shape of the triangle, they will always form a line. So as you can see in this picture, we have the orthocenter here, the centroid here, and the circumcenter here, and they lie on this green line right there. And same with this triangle, they always lie on that line. And the Eulers segment is created by the 3 special points on the Euler line, and there's a conjecture about the Euler segment that the centroid divides the Euler segment into 2 parts, so that the smaller part is half the larger part. So as we can see here, the area from the circumcenter to the centroid is going to be half of the distance from the centroid to the orthocenter. And this is a rule that is always going to be true regardless of the triangle, and that you can use in geometry.